Hello, and welcome to the Deploying AI Inferencing Workloads on an Ampere ARM64-based edge cluster screencast. This screencast demonstrates an OpenNebula deployment on a two-node edge cluster powered by Ampere ARM64 servers. It highlights the following key capabilities: ARM64 support and certification. It explains how OpenNebula natively supports the ARM64 architecture and has been officially certified on Ampere servers. It also showcases how ARM-based OpenNebula Cloud or Edge cluster can be automatically deployed using OneDeploy. Application deployment from the marketplace. The screencast demonstrates how to download and launch an ARM-compatible application directly from the OpenNebula Marketplace, simplifying Edge workload provisioning. Finally, it shows how to use the Ray deployment framework to run an AI inference workload using a pre-trained model from the Hugging Face, showcasing the platform capability to support real-world AI applications at the edge. The whole OpenNebula deployment is presented as a code, allowing the flexibility of configuring the whole cluster, including storage and networking upfront. Since the whole environment is presented as a code, it makes it much easier to replicate the same configuration, configure or further extend the cluster, or deploy multiple samely configured environments at the same time in the automated fashion. In the scope of this demonstration, we are having the Ray appliance downloaded from the OpenNebula Marketplace. An appliance is made for ARM64 architecture and configured to be deployed with QWEN 2.5 model from Hugging Face, then instantiated and deployed to an Ampere ARM host. As the final touch, we are going to interact with the model using the built-in ChatBot. Firstly, let's get the appliance from the marketplace. Marketplaces can be public, private, or community. Under the Storage Apps tab, we can search for Ray appliance. Please note that in this case, we are going to use the one that's built for ARM64 architecture. To download it to the OpenNebula environment, press the specific import button. During the import wizard, we are being asked to select the image data store that's going to store the Ray image. We are going to proceed with the default image data store. Once the image is ready, we can proceed with the instantiation of the Ray VM with an inference model. As this template was pre-configured beforehand, we don't need to adjust any of the parameters. However, should you need that, that's the place to adjust the virtual machine resources. I'm going to set the name to Ampere Ray to distinguish it from all of the others virtual machines in the future. Now, the user input screen allows the fine-tuning of the appliance, like setting the temperature or changing the prompt. Since we're talking about the edge cluster and power efficiency, we might want to run the smaller models here. For the purpose of this demonstration, we are going to use the QWEN 2.5 0.5 billion parameters from the Hugging Face. Since the virtual machine comes without any network attached, we must create and attach the network card to a certain network. While attaching network card, you can fine-tune the network settings should you need to. The Ray VM is in the process of deployment and supposed to take a tiny bit of a time. Ray also comes with a set of tools so you can observe the deployment process from the command line. Currently, as we can see, the model is in the process of deployment, so we need to wait until we'll get the complete message. For example, let's ask what is the capital of Belgium? And as you can see, the model replies quite quickly and correctly. Also, let's ask to perform some mathematical calculations. It takes a little bit longer than telling the capital city of Belgium, however, it's still quite fast. The screencast is produced in the scope of ONEnextgen project. Thank you for watching and see you in the next screencast.